on these doors that you've got here, you can see the height, you can see thickness, you can see weight, and it tells you what level, right? Whether it's in level 1, level 2, level 3 in that building, and it gives you all the family names. For example, this single flush door here, it gives you a family name of that particular object as well, and you can actually um, import the whole design into this custom software, and this software is Costex. Actually, it's Costex. There are other ones like CostOS particularly, and there's also Cellbeam, but we're not talking about those softwares today. So we're actually um, looking at focusing on the capabilities of Costex as a custom software that you can use quickly to generate quantities and then to interrogate designs and also query um, some lack of information within some elements of those designs. Um, that leads us to actually what BIM um, um, can do in today's modern technology. And I've put here BIM uses modern computer technology to create a 3D virtual representation of all aspects of a building design, construction, and operation. So a BIM model. And just to make a clear distinction there, a BIM model is is the product itself, but the modeling of that model is the process. So there's a process that generates the product. The process is the modeling, right? But the model is the finished product. Is the what is the final thing that you see, you know. So it uses modern technology to create that 3D virtual representation of all aspects of building designs, construction, and operation. It does not just stop in cost estimation or generating, quantities and costing pricing those quantities and then coming up with a contract sum. It goes into constructions phase of a project. It also goes into operation and maintenance of that. So it's quite vast, but for the QSs or managers or cost consultants, the focus majorly is on what is called 5D BIM. So the fifth dimension of BIM deals with cost and all the costing aspects of a project. And again, monitoring and managing or controlling that cost just to ensure that whatever budget or whatever cost has been baselined from the very outset of that project is not exceeded in the end. Right. So the model contains various building elements. It's grouped in families, like I've said, and then they are made up of building blocks or objects, right? So if it's a 2D design, what you see is line, right? So I'm going to be making that distinction between the traditional 2D design and also a 3D model designs. Then I'm also going to show the capabilities, what you can do, even though drawings might be in lines in 2D, what you can actually use the software to do to create 3D, which we call extrusion of 2D into 3D, right? And so you can it groups it into families which are made up of blocks or objects, and it's a database in the program containing detailed data about the objects. So the object properties will tell you the width, it will give you the length, it will give you the volume, it will give you, for example, I put down the line there. I'm going to show you a particular um, data extract we had to use to query a certain design because those elements were not um, the quantities of those elements were not clear. So we just had to say, okay, these and these and these features are not embedded into this design. Can you please update your design and then send it back to us? And the designers had to update the designs with those information and send it back. So I'm going to show you that down the line. So it's a multidisciplinary project team that uses model-based technology to share model data and collaboration on design, construction, and lifecycle management to produce better buildings. There are several capabilities of BIM. It can give you a visual communication of what you're dealing with. You can actually extract, you can strip a whole design to focus on the element or the component that you actually want to interrogate with respect to cost, if you like. So if possibly you've measured something and then you're not quite certain, you can actually zoom into that particular element and then focus just on that alone until you're 100% certain that what your measurement is accurate. And then you can then go into other things. It gives you that visual communication there. It does simulate and analyze appearance as well. That's one of some of the benefits of BIM. Just 1 second, I need to reduce this editor a bit. So it does simulate and analyze appearance, cost and long-term performance of the building. It does select the best options. Part of the benefits is that it will quickly and easily create detailed design information. It would improve efficiency and time saving. Also to save time and money. It will validate and optimize project plan years before you start on site. Higher level performance also through review, visual communication, like I've mentioned, you can visually see what you're measuring, not imaginary, because on 2D you do a lot of imaginary stuff, but on 3D you can see what you actually the takeoff you're doing and actually the properties you're dealing with. It would and also that's a cooperation in a digital and interactive visual environment, like I did say. Visual environment in the sense that everything you're doing, it's actually situated within a common data environment platform. You see that it's an intranet or a cloud-based platform, whatever it is, but you can, that's a visual environment within which all this operates. But that doesn't mean that the cost consultants or the QSs cannot um, um, work outside those environments if they want to, but it's always more interesting to work together, make your input, and then get an output back as an input into the settings of what you're doing. Then you can also test, you can validate and optimize project and cost plan years before you start, and then you can test and prove design before work starts on site. It does save time and money, particularly in early class detection, interoperable CAD capabilities, creating, editing, analyzing, and tracking multiple project views side by side. Can we mute, please? And then further benefits of these is, there's a detailed design information which can be quickly and easily created, and that improves efficiency and time saving again. The appearance, cost, and long-term performance of the building can be simulated and analyzed to select best options. Like I said, there's advances in software interoperability, which allow all members of the team to contribute to the BIM process, and it does act as an enabler for integrated project delivery. So now coming down to the major thing that I wanted to talk about today, that is 5D BIM and 4D BIM, but we're gonna just focus on 5D. So the 2D is basically the CAD design or traditional 2D designs, and 3D is basically the model. 4D deals with time, which we're not going to look into today. And then 5D is basically cost, which deals with money. So why 5D BIM? it does improve the capital and whole of life cycle cost outcome. That's the major performance metric. There's a speedy dimensional data extraction, which means that you can process more data more quickly, so you can provide reliable advice within a much shorter time frame. So, if, for example, if your design, if what the client is willing to spend, has a ceiling and you cannot go beyond that. In other words, you are not costing a design rather than you're not costing a design, you're designing to a cost. So if you're designing to a cost, then that will really help you provide a reliable advice as that design is developing rather than waiting to complete that design and then providing that advice as in retrospect would cost much more. But while that drawing or what that design is developing, you can actually provide a reliable advice. And then the designers can quickly, look at options to ensure that that cost ceiling within a certain phase of that design is not, or within a certain, elemental breakdown structure is not exceeded, or within a certain cost breakdown structure. So with this, you are able to break down the cost as early as possible and then just ensure that the cost ceiling is not exceeded for every phase of that design. And then it does allow QSCs and estimators to collaborate more closely with designers and owners throughout design and construction to actively drive better cost and whole of life outcome. And then again, with digital estimating software, there's a universal application ranging from hand drawing sketches, PDFs, 2D and 3D CAD files, and 5D BIM capabilities. It does read object-based BIM models to automatically extract object properties and the associated quantities using digital data, and that allows quantities and costs to be quickly and accurately assessed within a live electronic environment. So what basically happens, it's, for example, this is a conventional 2D design. It can be either a PDF, it can be a DWG drawing, it can be a DWF drawing, it can be a DWFX drawing. So depending on the tool the designers are using to design, right? They can design with, let's say, AutoCAD. They can design with Revit. They can design with, graphic card. What's it called now? ArchiCAD, which is Graphisoft, product. They can design with any design tool. Um, um, they can come up with 2D designs, and then once they get that, sometimes they convert it, it's converted to PDF, then sent to the QSs or estimators. Some other times it's sent, you know, it's sent from the native file, right? So if it's sent, for example, AutoCAD will give you DWG drawing. So that's a native, file of AutoCAD, and then that can come. If it comes as a native file, that's great because it's not going to lose a lot of intelligence. So it's not losing intelligence actually. However, if the estimator or the QS, the cost consultant, does not have AutoCAD, then he would not be able to open that design. So that's why sometimes, because of being able to access the design that's been sent, sometimes they convert it to PDF. But then when you convert to PDF, it will lose intelligence. What do I mean by that? Let's say you do something in Word document, and then you try to convert, particularly if you have lots of graphics, lots of figures and all that in a Word document, and you try to convert that to PDF. Sometimes you lose some figures, or sometimes there's an overwriting, of an existing write-up and all that. But that's not how it was in Word. But you're trying to convert to PDF. In the process of doing that conversion, it loses intelligence. And then the recipient will then struggle to begin to try to understand what is missing and what is lacking and what is not missing and all that. So same thing with a 2D design. If you send sorry, I'm not sure where the noise is coming from. If we can just mute ourselves, please. Um, so when the design, for example, this is a 2D PDF design. When it's sent, it loses intelligence. Some things that would come with native file, you will no longer see it. But again, even the orientation might also change. For example, if that drawing has been done 1 in 100 or 1 in 50 or 1 in 250, whatever scale that's been used to do that drawing, if you convert to PDF, it will lose that orientation. So you have to recalibrate. When you get that design and then you know that this is a PDF design, you export it, or you import it into Costex. Once you import it, in our next session, maybe I'll discuss with the QSI. The next maybe a couple of months time, I'll show you how to actually literally do these things right in softwares. But I need you to understand the background very well first, and then can then get into the software, and I'll show you how to get all these things sorted. And then you import this design into um, the software. The very first thing to do is to reorientate that design. So you've got to choose you've got to choose any of the walls or whatever you like to choose, right? Any feature, any element, and then just measure it and just check whether it's giving you the accurate dimension for that particular um, maybe a wall. You need to check, or a door, or whatever you like to choose. You just check whether it's giving you the accurate measurement. And of course, definitely PDF will not. So you have to reorientate it. You just have to reset and then recalibrate. That's features to use for a calibration on this within the software. You recalibrate and get it to this design to the scale, that initial, you know, scale it was designed to. Then that way you can then get, for example, if you have 4,500 millimeters, for example, if you measure that without recalibrating it, it might be giving you something like 10,000 millimeters or whatever, something that this is not possible, right, within this particular length. So you need to recalibrate. Once you recalibrate and put the right features in, or put the right scale in place, then you come back again and then you remeasure, and they will give you the exact 4,500 millimeter, with that example. It will give you the exact that, and then you save that. Once you save that, you're fine. You can then begin to, do your measurement down there. And then it can give you this is a conventional 2D CAD design imported into a beam custom software Costex. It's called RIB I2. So it used to be exact. It was sold to RIB I2 Costex is called now. So imported into a beam costing tool for quantity takeoff and generation of cost information. You can actually all these areas you see me generating, all these floor areas here, is just a click of a button, right? It's just a click of a button depending on how you've set it. You can set it to just click a button, it will highlight what you're looking for, or you can use points. You can use, points to actually go around the rooms, and then once you're done with the last um, point, it would generate the area for you, right? That's how I've generated these areas. And if you just want the quantity of the wall, for example, this particular wall, this long corridor here, it will just give you that quantity if you don't want the area, depending on what you're looking to do, right? And then from importing that design into the software, you can then, the moment you want to start generating quantities, right? Whether you're generating, wall quantities or floor areas or whatever you are looking to do, you would have to open what is called dimension group. In that dimension group, within the software, that's where you generate all your quantities, and it does not take time. Everything you're seeing here can generate within the next 10 minutes. I mean, depending on how quick and how fast you are. But if a traditional QS, or a traditional cost estimator picks up this, it's going to take a far longer time to generate all the quantities here. But within 10-15 minutes, I can generate all the quantities in this design, right? So, and that would happen, you know, within dimension group. And then if I feel I've missed anything at all, I can do my extrusion. So there is, if you see on top here where my cursor is, you see view in 3D. So what I've measured here, like I've measured some windows here. So what I've measured here, you could actually just a click of a button, and it would give you the three-dimensional view of your measurement, right? Like I measured the areas of this, so it would not, because it's just floor area, it wouldn't give me height because it's only floor area, right? But because this, I measured the walls, and in my the parameters that I put in the height of the wall, right? I just put in, okay, I want the height, I want this, I want that. Once you put all those within the dimension group parameter features, it would produce what you're looking to produce. But if you're looking at at that digital measurement from this perspective, you might not really know what you've measured, because it will still be as flat and horizontal as it is. But then if you really want to know what you've measured and to know whether you've missed anything, for example, well, when we do the actual demonstration now, I'm going to get two identical drawings, right? I'm going to get two identical drawings, the DWG and the PDF. And those two drawings, it's still the same drawing, but converted. However, there's a little bit of, there's a slight change. And if you just measure without extruding it into a 3D view, you would not be able to know what those differences are. And these are the things that, the oversights or whatever that the QS is, the estimators will always miss. And then we'll be shooting ourselves in the foot if we don't, cover all the costs in terms of that will reflect in a shortfall in our material supply. It would reflect in shortfall in pricing. It would reflect, even in the cost of labor, right? There'll be deficiencies, or there'll be shortfalls in there once we don't have accurate measurements, right? So that was why after measuring, I had to, extrude into it's called 2D 3D nexus, if you like. So I had to extrude into 3D to actually know that I've covered all the doors that I'm seeing here, or the windows, sorry, all the windows that I didn't cover it all here, all the windows that I'm seeing here, just to be sure that all the windows are all covered. And again, um, sometimes when you're measuring, you can also measure a toilet, window, as though you're measuring a whole window. Sometimes that oversight comes when you're doing it, traditional measurement. That oversight comes. But again, on this, once you've done this, there are some toilets here. You can see there's toilets, and then there is WCs and all that here, which the windows would have been shorter. And then when I extruded, I saw that, oh, I've made that mistake. I've measured them as though they are normal length windows all around. So this now would tell me, oh, no, you've not gotten it right at this point. So at this point, you actually needed to, these are toilet windows, and the length is not or the length and the width is not as much as you've measured. And I can see that clearly there, right? I can see that clearly. And again, when you add the doors, like I've added the doors here, I've added, now that I've measured the external wall, I've measured part of the internal walls in this long corridor. I've also measured the doors, so I can also extrude to see how these windows fit into the external wall. right? And then that tells me that I've made mistakes in these particular toilet windows. It shouldn't be, the length is wrong, right? Which again will cost waste if those materials are to be supplied the way I've measured and quoted them, right? And then and then I'm just looking at our time. Yeah. So this shows you doors, windows, and building envelope with corresponding quantities. Mistakes can easily be detected. And then again, it's possible to filter 2D CAD design components in 3D view using dimension group to ensure cost information is as accurate as possible. If you look at this, you can see my long corridor here. But just to be sure, I have all the doors measured, because sometimes again there's an oversight and you miss a door, right? Or where a door should be, the door is not there, right? Like there should be a door somewhere here. And then when I extruded, I actually noticed that this designer has actually made a mistake without putting a door here that's leading into the lounge or something like that. So, that again is for you to flag. That is why when these things are being done as the design is developing, you are able to provide, on time or real time, um, 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 or just in time advice, and then they actually see where they're missing things. So again, if you then want to check that all your doors have been captured, you can actually do that filter. So you can take out the long corridor, right? You can just take out the long corridor, disable the long corridor, and then all what you're seeing is the doors. If you also want to check the family of doors, whether double doors, single door, whatever door it is, you can also look at them by families. You can look at them by families. So if for example, I want to see all double doors, and if there were double doors here, which there's a double door somewhere here, again, which I've missed, there's a double door in somewhere here, which I've missed. Um, Again, I would also flag that in my measurement to say, oh, there's something I'm actually missing. And then again, if you get to this point, this extruded into 3D now for visuals. So everything that I've measured, I extruded, and I can change the coloration to whatever I want. Um, you know, Particularly I love chocolate color, so that's why you're seeing chocolate in there, right? So you can do your extrusion to check everything you've measured, to sit on that 2D design, and then you can actually just be sure that everything you've done is fine. And like I said, if it's a native file, you don't need to recalibrate. If it's a PDF file, then you have to recalibrate to actually ensure that the scale you're using to measure is as accurate as what was used for the design, right? Otherwise, you get wrong quantities everywhere. And if quantities are wrong, then your pricings will be, off the cycle. And then again, there's a possibility of also importing a 3D. This is a 3D model. It's a BIM model. It's a data rich model. Every information is embedded. So if it's a live software, I would have been able to show you properties of this, the roof, everything. The properties are all embedded within these objects, right? So a 3D model design and a BIM costing tool with some hidden building objects, allowing a clearer view of model design inputs and design queries as well. Same thing here as well, exterior 3D design view with a display of object properties and cost modeling attributes to support model mapping of extracted quantities. So you can actually model map. That's what it's called, model mapping, if you're doing a 3D BIM quantity takeoff. So you can actually do a model mapping of extracted quantities, and then it makes it much easier to query required model attribute not designed, right? So you can actually find this, what I was telling you, that when we did this in one of the projects that they were doing, we actually found that some of this elements, the width, the area, the length, the volume, were not really captured, and we had to send it back to them, and they now had to input, all those values for us. And then I just wanted to show you that example. Sometimes the designers, because they are not QSs, they are not estimators, they are not cost managers or cost consultants, they are much into seeing the aesthetical value and the functionality of the building they're designing. But it's our responsibility then to then say, oh, you've done this particular object, but the volume is not showing, the length is not there, the area of this particular floor is not there, and all that. So, and then they would quickly generate those and input back into the design for you. And when you've done your measurement, you can also make your model a ghost model, so to speak. So it makes it very transparent for you to actually see, internal object very visible. Like you can look at this and you can spin it all around. Really, it's not cancer stone. It's just these are some screenshots that I've captured. You can spin it all around to actually see what you've you know what you've done or what you've measured. And then you can use coloration as well. Like you can see all these colors that I put here, right? It's the colors I chose to measure different things. And then when I'm extruding and when I'm looking at what I've measured, or if I just want to look at a certain element that I've measured, I'll just highlight that element within the dimension group, and then every other thing would go. And I just want to look at that particular element and interrogate it properly. Yeah, so there are lots of possibilities for digitization or for digital measurement processes, and everything, like I said, is more underpinned by BIM. So you can see the QS here is imputing information back as an advice to say, oh, we have a cost ceiling here, we have £5 million to spend, and then in the phases of this particular design, this is a cost ceiling per each phase of this design. And I think the maybe substructural phase or superstructural phase or whatever phase it is, you've actually exceeded. So this is where I think the cost um, 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 issue is coming from. And then this element, actually we can actually look into it and then see if there are alternatives. For example, um, um, I had a discussion with someone in one of the organizations, Arab actually, and then the cost manager was telling me how they were able to use a custom software to actually reduce the costs of a certain duct pipe that they were installing at some point in a very huge infrastructure. So he said it has come as 900 and then this was going over the cost ceiling that they actually put together. And they were like, if we reduce this thing, if they design this thing to be 600 diameter, will it not do the same work that this 900 would do? And then in the end, they actually agree with the design team that yes, I think you guys are right. And they just cut down from 900 to 600 and then that saved them a whole lot of cost. And then that was done because it was they were looking at a beam model like this, and were doing the interrogation of those elements, and then advising, providing real-time advice at the same time. So this follows more of a process, really. It can support integration, coordination, visualization, analysis, fabrication, whole life modeling, right? Whether it's architectural or structural designs, whether it's MEP designs, services design, or whether it's um, um, whatever project, or sorry, whatever design it is, you can always import these designs into a custom software. However, if you're an MEP um, uh, cost estimator, then you need to really master that area. If you are custom structural elements, you need to master that area, because just like we know, there are quite a number of knowledge that underpins um, um, cost estimation, underpins quantity takeoff in different. So if you're looking at um, building designs, and then you just ensure that you have the right expertise and the right knowledge to do that. If you're looking at structural or any infrastructural stuff, you need to understand your systems very well, so you can actually use those knowledge to underpin your takeoff, and then your ability to price those quantities you've generated, and then come up with an estimate sum for that particular project. So again, like I said, it's all underpinned by BIM. The client is making an input into the model, and then the cost consultant is also making an input into that model, and then everybody's input becomes the other professionals. Everybody's input into the model becomes an output for the other professional to work with, and then when they look at it from there with their expert opinion and their expert judgment, their input back into the model becomes the output for another professional to work with. So it works very well when it's is done in a CDE platform, right? Or whatever you've done, then you upload it back, and then of course when you use platforms like For Projects or other CDE platforms, then you'll be able to everybody with access to that platform will see the updates that has been done, whether it's architectural design update, structural design update, or cost modeling update, or even scheduling update. Everybody will see the update that's been done on that model. So there are certain things that people think is BIM, but they're not quite BIM, in terms of CAD, in terms of other, you know, 3D designs. Because it's in 3D does not really mean it's BIM, and then you can easily extract quantities out of it. If it does not, if data is not embedded, within the properties of those elements, then it becomes difficult, and that is not seen as BIM. It's only when it has data embedded and you're able to extract those data for your cost information or your cost estimation processes, then that's when it works. Just because of our time, if you look at this again, like this is quantification of a structural design. So from the piling to the columns to the beams to the roof, everything you can actually extract all those quantities, right? You can generate the floor areas. If they're concrete based or reinforced floor areas, you could actually, generate those quantities as fast as you can. You can harvest those quantities, as fast as you can, and that reduces your takeoff time very dramatically. So again, when you're done doing all that, this is workbook here. What I've shown here is workbook. You can open your workbook. So far, you've done everything accurately within the dimension group, and you've interrogated everything, you've checked whatever. That's why using color coding is very good, because any particular element you want to look at, you can just highlight that element you've measured within your dimension group and go back to the drawing. It will show you this area is what has generated that quantities in your dimension group. And then you can, once your dimension group is accurate, all you need to do is open your workbook, set it up. It's like Excel. It's like an Excel spreadsheet. However, it's a little bit tricky. It's just, if you work on workbook, Costex was workbook one or two, three times, you will be able to get your head around how it actually works. And then you can then drag and drop. Just drag and drop and drag and drop. And then each of these is turning green. These green colors means that you could actually, double click on it, and it takes you back to the particular element that generated that quantity if you're in doubt, right? If you're in doubt, it will take you back to the drawing to show you this is where this element came from and all that. That's why you see them you know, in green, and you can, put all your units, put your rates, and then have your subtotals and all that. There are a few, things to impute within the workbook to ensure that you don't make mistakes. Like I said in one of our sessions, I'll be able to demonstrate that maybe in the near future. And then how can BIM help the QS? It does enable a rapid analysis of comparative designs, what if scenarios, whole project cost and time savings. It does increase accuracy, um, and greater certainty of costs, and quicker feedback of cost to design team at an earlier stage, and more collaboration on design involving the QS. I was with one of the top directors in a tier one construction firm in London, and he was actually telling me how they were able to use QR Castex to generate a quantity of a whole building within, in fact, half a day. But I said that there are QS that measures traditionally that generates quantities and develop BFQ. Traditionally actually spent 3 weeks on that same design. But the young chap who just graduated and has been taught some costing um, softwares just say, okay, can I have the copies, the PDF or whatever? And they sent him, and he said half a day that this guy came up with, and he was still more accurate than when this other gentleman finished in 3 weeks' time. So this is how quickly you can generate the quantities if you actually, take your time to develop this expertise. Right. So you can visualize, you can interrogate. Like I said, if you get to workbook, you can walk, backwards. You can backtrack to know what you've missed and what you've not missed, what you've left out and what you've not left out. So you can visualize, you can interrogate, analyze, test, evaluate, validate, and collaborate. And then that it's what we have looked at today. The possibilities of being able to um, digitally quantify both your 2D designs and your 3D design and the capabilities embedded within this particular software we've looked at today. So that brings us to the end of this presentation today. Any questions, please?